We're live. We're live. Cool.
Yeah. Hello, hello, hello. Welcome to Twitch Stream Thursdays. My name is Mofi. I'm a developer advocate at IBM. I have Nick with me.
I'm Nick. I'm also a developer advocate at IBM.
Yeah, so today we're talking about Kubernetes. So I'll be presenting. I mostly work on container microservices stuff. And Nick is going to be here, helping if you have any questions, post it on the Twitch Streams chat. Nick is going to be looking at that. Nick also has some questions, I believe.
Yeah, a lot of stupid questions. I've never done Kubernetes, so he's going to teach me. I normally deal with AI. And,
yeah. So basically, this Twitch streams we have almost every week we're going to try to do. Nick does a lot of AI stuff, which I'm interested in learning. I do a bunch of Kubernetes stuff that he's interested in learning. So we're going to kind of like share knowledge. And we just thought we're going to bring you on the journey with us and, just basically share the knowledge we kind of have to everyone else. So without further ado, I'm going to just get started real quick. So if you're here joining with us in this Twitch stream, I believe you have some interest in Kubernetes, or you're either using Kubernetes or want to learn how to use it. So before you get to the point where you have to like run Kubernetes, that means you have some sort of workload that you want to run, or you have an app idea that you want to run. That's the kind of the title of this talk today, App Idea to Kubernetes. So when you think of an app, basically, what would you think about?
Like an iPhone app?
That could be an app, sure, yeah. But like Kubernetes mostly doesn't really deal with UI things. You could run UI front ends on Kubernetes, but it's mostly useful for people that are trying to run heavy back-end loads on Kubernetes. Even in your iPhone app, you need something to run that in the server. So that would be better suited for Kubernetes, right? So let's say we have a back-end app. We want to run it somewhere. So traditionally, where would you run it?
On the cloud.
Right. So again, that answer is like, a great cloud-native world. We're running things on cloud. But not everybody's there yet, right? People are still running things on bare metal, on their VMs, which works for many people, but that's not the best way to scale things, right? If you have a bare metal, you're basically saying, oh, I need more compute power, order a new machine. That takes time if you have your own sort of like data centers, right? So that's the old way of doing things. You request a new server, it takes like 3 weeks to get delivered to your thing. Someone goes out there, plugs it in, it works, it's great. Eventually, we kind of moved on. We kind of got VMs, right? VMs are pretty great. You have some provider or like your own data center. You just say, I want to provision some VM for me. You get it, right? So you get the VM and you can do whatever you need to do on the VM. But the problems with VMs were that if a VM went down, if you remember, like people actually like had sysadmins that would log into the VM and try to figure out what's going on the VM and fix it, which worked in practice. But it was not the most scalable thing because each and every VM kind of became their own thing. There is no such thing as like uniformity, or you can just scale a VM up to get the same exact environment easily. So the problem was that the idea of like kettle versus cats comes in, right? Kettles versus pets. Yeah. So kettles versus pets, right? So you have these pets VMs. You kind of gave it like nicknames. Oh yeah, that's that VM, that is that VM, and this VM has this environment, that VM has that environment. And you are just running your workloads in different VMs. As we kept scaling and scaling and scaling, that wasn't a model that we kept building up on. Then the idea of Docker came in. So Docker, in many ways, have you dealt with Docker at all?
A little bit, but it's a little bit over my head at the moment.
So the idea of Docker container engine is not like super new per se, but they gave it like a really nice API, so it became very accessible for people to use containers. So container is basically just a resource level isolation on the Linux host system. You basically separate out some resource with a namespace in the Linux system or your host OS system. So what that meant, you can have these things called containers that each of every single copy of the container can be exactly the same, and you don't care if one of them goes away, one of them comes back. So that is basically the building foundation where like it was like ready for something like Kubernetes to come in, and that's where we're going to talk about Kubernetes. So they have probably seen our face long enough. I'm just quickly going to switch screen to my screen. So we did this talk kind of as a workshop a few weeks back, but I think the talk part of the workshop, I think that a lot of good information that I want to actually like go a little bit more in depth with. So this stream today is kind of part of a bigger series that we're trying to start. Today we're going to kind of have a big overview of the whole ecosystem, from like an idea you have to how does it go into production. But eventually we probably want to like talk about each and every single path of the whole process. So how do you write your application the right way? Kubernetes doesn't really discriminate what application you run on Kubernetes, but if you have the proper path set up or like right things, how you handle configs, how you handle secrets, it's a little bit different in Kubernetes terms. So you're gonna like kind of dive deep on all of them at a later time, but today we're gonna just like have a broad overview. So I know you created an application and that's running on Kubernetes. We worked on that together a little bit to run that on Kubernetes. How was that experience like for you?
It was running a lot of commands that I didn't understand what they were doing.
Yeah, so Kubernetes being like such a new thing, it's the ecosystem is not as built to the point that you have like nice tools, right? For example, for CI/CD with Kubernetes, there is no like this de facto answer. People can just say, oh, that's the way to do it. There's many ways you can get it done, but not necessarily like one best way to do things. Part of the reason for that also is that Kubernetes, as I said, doesn't discriminate what you run on it. So you could run any kind of workload. People usually run web apps and web backends on it, but you could literally run anything that you can run on Linux machines by Dockerizing it. You can run it on Kubernetes. So for Kubernetes to come and say this is the way to do things is a little bit difficult. Kubernetes is a little bit more forgiving and a little bit more open-ended in that way. Okay. So this page that you can see on your screen right now, I call it Kubernetes Shallow Dive. It's because, again, in like a very short span of time, I'm going to drop everyone into like a shallow end of Kubernetes from a very high top-level view. Initially, when I said the word shallow dive, I actually thought it's a word I'm making up, but it's actually a real thing. It's kind of extreme sport where someone will jump from a very high point to like a feet or 2 feet of water. It's crazy. Yeah. So this is like this tweet right here by Kelsey Hightower is one of the very core thing I want people to understand when they talk about Kubernetes. Is that when many people think I have an application, I'm going to put it to Kubernetes, bam, done, happy days, we're going to go home. But for most people, that's not the end of the story, because so back when we were talking about VMs, and now you talked about like you put your application on cloud. You just touched upon two of the big things. We talked about IaaS, infrastructure as a service, and then we talked about PaaS, platform as a service. And many people kind of try to put Kubernetes in either or in the boxes, like it's an IaaS or it's a PaaS. But I personally don't think that's either of those, because you have Kubernetes where you have the Kubernetes taking care of some of the infrastructure stuff, but it doesn't necessarily cover all the infrastructure stuff. It also doesn't do all the platform stuff. You have to still control some of the things. You have knobs and buttons you have to press to get it to do the right things. So it's this is like the perfect example of what Kubernetes is and what it isn't. It's a platform to build other platforms. It's gonna be kind of geared towards what your application needs are. You can't just say like, "Oh, I got into Kubernetes and I'm done." That's not where it ends. You need to fine tune it. You need to properly manage the resources to do exactly what you need it to do. So what is Kubernetes then? So we spoke briefly about Docker, what Docker is. So Docker gives you this container platform. You can wrap your application nicely in this container image. Then how do you then scale this image? You can run manually Docker stuff. You can run each image separately as a whole. But what if you need 20 copies of the same application? What if you want to say, if I have a lot of resource, if I don't have enough resource, scale it down? Or if I have a lot of resource, scale it up? If you have a lot of requests coming in, scale it up? What if some container dies, right? If you have an image running, if you have application running, it dies all the time. So how do you deal with that? So these are the questions that came up over and over again that at some point people had to ask, we need something better. And funnily enough, Kubernetes was not the only one at the time when it started. At the time, we had Mesosphere working on Mesos. We had Docker, actually had Docker Swarm at the same time. We had Kubernetes, obviously. We had a bunch of others actually in the same ecosystem at the same time, doing kind of the same thing, but not exactly the same way. But eventually, kind of Kubernetes being open source project, starting from Google, had a lot of like industry backing, and eventually it became the leader over the last couple of years. And if you now look at container orchestration platform, Kubernetes probably is the only way to do it, the main way to do it. So it's a container platform. It's a microservice platform. Now another heavy, big word, microservices. So what is your understanding of a microservice?
I think it's just a bunch of little services that all talk to each other instead of just having one giant thing that does everything. And then I have a little question. So does Kubernetes, is that like a replacement for Docker, or do they?
No. So yeah, so that's actually a great question. A lot of people have the same question that, I did Docker already, do I need Kubernetes as well? Kubernetes manages your Docker images. It's not competing with the same things. So Docker builds your images. It's a little bit lower level than Kubernetes. And Kubernetes then takes those images and runs multiple copies as you need to. So yeah. So microservices, that's a great explanation. It's like smaller things. So I think microservices was another big reason why Docker and Kubernetes became so successful. Because back in the days where you had like a big application, a VM or a bare metal made sense. Because you had one application, it's running on one place, you manage it, you don't let it die, you just put people on 3 o'clock on the phone call to make sure if it dies, they bring it back up. That made sense because you had one big application, right? But when the microservice thing just kind of like blew up and everybody wanted to build microservices because of numerous benefits, and that's a talk on its own, why should we build microservices other than monoliths? But when we had that, now we had this application chunked up in, say, 20 different parts, and each of them are running independently almost, and each of them can be independently deployable. So previously, when you had this one big application, deployment took let's say 3 hours, but it was just one deployment. You just crossed your fingers, crossed your T's, dotted your I's, and hoped it worked. And after 3 hours, if the deployment was successful, everybody went home. It was done. But now you have 20 of those things happening. Each of them doesn't take that long, but that means you have 20 more times chances of failing. And then you can just get into the spiral. This failed, then that makes something else fail. Just like a whole thing. So you needed something better so that you could independently scale them as you needed to. And microservice also makes sense because, let's say you are like an online shop and you have a lot of traffic right now because of some sale, everybody going to some electronics pages, right? Electronics department. So you probably need to scale that side of the website up, not maybe the promotion page, not maybe the cart page, but that side of the page. If you had that monolith, if you wanted to scale this thing up, you then scale the entire application up if you need to. That means, first of all, it takes longer time to scale. Second of all, it costs you a lot of money because you're scaling this whole application that probably doesn't need everything to be scaled up. So Kubernetes made sense because it can scale individual parts. But then the problem you said, there was a lot of commands that you had to run. And I wish I could tell you there's a better way to do this. Like there's this one other thing you can just press, it does everything. There are some other solutions that helps you do this, but Kubernetes is still super, super young. It's gonna turn 5 years next month. So happy birthday, Kubernetes. So it's gonna turn 5 years of the open source version of Kubernetes. But like as far as adoption goes, it's just started seeing adoption like for the last 3 years maybe. In the meantime, we actually had a lot of like new projects that built up on top of Kubernetes. We have had really great monitoring and logging services that was built on top of Kubernetes as well. Okay. So yeah, so we have a lot of like logging and monitoring service on top of Kubernetes, like Prometheus, Grafana. And if you actually like kind of move on a little bit more, now we have things like Istio that helps like with service mesh. Again, different talk, like a lot more in depth, but we're gonna actually cover all that. But I just wanted to kind of give you like a big idea of the ecosystem. So before we can understand like what something is, it's actually a good idea to understand what something is not. And Kubernetes, again, it's not something that controls what kind of application you put on it, right? Kubernetes doesn't really say anything about what you have to do to log or monitor. It doesn't like make you log or monitor yourself, like your application. It's a good idea to do it because if something dies, you want to know why it happened. So also Kubernetes, as of now, built-in doesn't have any way to build your application. Kubernetes, once the application is built, the image is created, you can run that image, scale it up, but it doesn't have a native way to do it in Kubernetes, which is probably going to change soon because Knative as a project is up and coming. Knative has a built component on Kubernetes itself. But again, that's like a whole new project. It's on version 0.5, super new, super young. It's happening. Kubernetes doesn't have a built-in CI/CD platform onto it as well. So you might be thinking, that it's a terrible project. It doesn't have a lot of these things. But I think the idea of not having these things built into Kubernetes does two things. One, makes the project a little bit more affordable for people who wants to just like have smaller things. Because if it has a lot of different things in the same package, people who just need some of it can't take it. It just be like, oh no, that's too much. I can't do that. So you can have all these things by plugging in different things, but it doesn't come out of the box on Kubernetes. Gotcha. But things that come out of the box, I think you're gonna like this one. Auto scaling comes out of the box. Self restart, self healing, health checks comes automatically out of the box. You could do resource quotas, resource allocation. You could do user management by creating service accounts. We can have built-in security authentication of each user and each command that comes in. With some third-party tools, you can also get authentication from each request from each service to each service. You can make that authenticated as well. Kubernetes has some level of built-in service discovery. So microservice world is a crazy idea to find. So you have like 8 different things in your big monolith. How does app A finds app B, right? Now you have to like manage your own DNS entry. And so you remember DNS stuff. We tried try to make some website things work, and DNS is just difficult. So Kubernetes does give you some DNS capability built into Kubernetes. You can add some other things to make it even better. So we talked a little bit about why should you use containers versus VMs, right? It's easy, you can get rid of it and make a new copy of it. But there are some other benefits to it as well, mainly because it's much, much, much smaller. In comparison, when you talk about the Ubuntu VM, that might be like almost a gigabyte in size. In the same application, if you're running on a container, you can bring down that application size in like 10s and 20 megabyte, which is 50 times smaller, 100 times smaller. It's much smaller, right? When something is smaller, that means in the same resource, you can actually run multiple copies of it, which is, the more copy you can run with the same resource, the more money you save. So quickly, just talking over what does Kubernetes have. You as a user, you come in as like making CRUD operations to the client, mostly using the kubectl, the CLI tool. You have a database that keeps access of the current state of what's happening at Kubernetes. So Kubernetes, another thing you're going to notice when if you did any Kubernetes, and we're going to see it in a second, if you make any request to Kubernetes, it actually comes back right away and says that it's done. So mainly what happens is it just writes to this etcd database. But the changes that needs to happen actually takes a little bit longer to happen. So do you think like that is like, why would you think like that they did it?
Probably so you can just tell it to do stuff and then don't have to keep doing other things while it's working.
Right. So like there is like this async component, right? But like there again, two schools of thought, because sometimes you made a request, maybe you didn't have any more resource to run it, or maybe you didn't have the proper authorization that's going to be checked. But let's say the application failed to run, but Kubernetes right away, when you first time ran it, it'll just tell you it just finished, completed. But it can, when it fails, you're not going to know why like it failed right away unless you go and check. So in one hand, it makes it faster. You can just like run something, then run something else. But on the other hand, you ran something, but it didn't run, but it didn't check, so you didn't notice. So your application is not running, but you did your job, you went home.
Yeah.
So, but that's why you should have like good logging and monitoring system, right? So you want to be able to like tell. So Kubernetes has a Kube API server. That is the one that's handling each request you're making. What should the state of the Kubernetes be? And it looks at the etcd database to be able to do that. Then you have other things you need. You need to have network connection to be able to talk inwards and outwards from your application to the outside world to your application. Volumes. So when Kubernetes first started, it was supposed to be a stateless system. So there was no way to like, no proper way to store data. Your application was stateless, and everybody was like, yes, happy. But we weren't happy because, again, our application has some state, you have to store something. So Kubernetes eventually had this thing called volumes. Now you have volumes that you can store data in. So next up is, then we also need secrets. Almost every application needs something to like connect to like the database, store this API key for some service that you're using, preferably an IBM cloud. But yeah, so you have secrets that you can like do, like put that on as well. So environment variables, you also can pass that onto Kubernetes. We're going to take a look at that real quick. And last but not the least is your actual application that is running and however many copies you're running. So that's all part of this, like the ecosystem that Kubernetes kind of deals with. So Kubernetes has different parts, kind of like how Kubernetes functions. So there are some things that are hardware. Basically, no matter where you're running it, even in cloud, it's someone else's computer. There is some hardware component to it. So the first level of hardware is just the bare minimum you need is a node. It's at least one node. It has to be a master node, and so you can have master node and worker nodes. And node is something that have compute power. Anything. It could be like a local computer you have. You can run it on a laptop. I have actually installed Kubernetes on Raspberry Pi in my home. Works pretty well. So technically, anything that has some compute capability and network connection can be a node. So you have few of those nodes together, that becomes a cluster. Kubernetes doesn't really dictate what kind of nodes you need to make a cluster. It can be like mix of all sorts of node. And in production, if you're doing many different kinds of things, you probably want many different kinds of machine. For example, you want to probably have some machine that has SSDs for faster data processing. You want to have probably some with like GPUs for a lot of faster calculation. So it's kind of, you can mix it up and you can label them so that your app knows where to go when you deploy it. Next is volumes. So again, Kubernetes initially was stateless, but we wanted state, so we actually eventually added volume and stateful application on Kubernetes. You can store your data as you need to, and volumes are also a resource that application can access from the pods. So these are just basically in the bare minimum what you need to have your Kubernetes running. You need other things, obviously, but the minimum, that is that. The next up is the software requirements you have. So containers, these are what you talked about, Docker images. Right now, actually, there are many different kinds of container images that are out there, but Docker probably is the most used because it's the most accessible for people. But I don't know if you heard in the last couple of days, there was some, I think last week, there was some security breach in Docker. Their CEO just resigned. They're getting a new CEO who used to be the CEO of Hortonworks. So that's a lot of things are changing. But as of today, still Docker probably is the #1 leading used container runtime for Kubernetes. There are others like Containerd also works. As of version 112, IBM Cloud actually started using Containerd 111. 111, yes. As of version 111, we started using Containerd. Red Hat has also like a different kind of image. It's called Cryo. But the idea is you need some sort of containers to be able to run on Kubernetes.
Gotcha.
So you'd think since a container is like in one application image, that would be the smallest unit of deployment on Kubernetes, right? It makes logical sense, but it's not. And a lot of things that make sense, it's not. So it's actually a pod. So just by hearing the word pod, what do you think pod is? It's not Tide Pods, definitely not.
Okay.
Yeah.
So I actually no idea.
So it's fine. So I think you can think of pod as kind of like a pod in real life. You have like this we have a bunch of pods in the office space, and a couple of people can sit and work in the pod, right? So think of each of those person as one container doing their thing, and that pod kind of like gives them a space to do it. So each of a pod can take one or more containers, and each of the people that sits in the pod ideally works for the same group, right? So they're trying to achieve the same goal, but each of them probably does something different, okay, right? If that makes sense. So that's what a pod is. Now you have a pod. Let's say you have a pod that your application has a pod, but you want to have a container that handles database stuff. You have a container that does the application stuff, and you have a container that's UI. Together, that could be one pod. So
okay,
together.
So one pod can have multiple containers?
Yes.
So why isn't the container then the smallest?
So the isolation becomes a bit better in the sense that before you can containerize. So basically, you can make a container that has the UI and the backend built into one. But I mean, ideally, that probably should be a different pod to begin with. But just for example's sake, you could then have separate containers and build up the container separately, push the code separately, but then have them in the same pod. It's a bad example. I'm gonna give you a better example in a second.
Okay, whenever you said that it's the smallest unit, I just meant like that. It sounds like that there's pods inside of containers.
No, okay. No. So pod is the thing that's kind of like containing a bunch of containers. Yeah, the naming of things as industry we're not super good at, but we're good at many other things other than just the naming. But yeah, so pod. So basically, what pod gives you inside the pod, all the containers have the same local host, kind of. They can share the same volumes. They share the same network interfaces. So you can have some benefits with it. And actually, pods are not used to do front end and back end stuff. You should actually have separate pods for your front end and back end and other services. But a pod with multiple containers are used for many other things that we're going to talk briefly a little bit in a second. The next is a deployment. So a pod is, as I said, is the smallest unit of Kubernetes. But a pod by itself is pretty useless. It's the same problem we had with Docker. Because when you run a pod, it doesn't know anything about scaling. It doesn't know anything about other pods that has the same application. You can run a pod, and it's going to run. But if it dies, it dies. Kubernetes doesn't really restart the pod. But Kubernetes does do auto scaling and auto restart. How does it do it? Deployment. So deployment has this thing called a replica set. And replica set just keeps track of how many copies it should have of the said application. Let's say I said I want 50 copies of my application because a lot of traffic coming in. And let's say I only have resource right now to be running 45 copies of the application. So Kubernetes will actually say, yeah, sure, okay, we're gonna try to run 50 copies. It's gonna start scaling up. At 45, we're gonna run out of all the resource. So after 45, all the other 5 pods are gonna stay on pending because there is no resource. But let's say I kill some other application on my cluster, then all of a sudden resource open up, it's going to scale up to 50. But the idea is, no matter what happens to your cluster, as long as the deployments are not deleted, it will try to keep the number of replicas you wanted always the same. So how do you think that becomes useful for you then? Or your use case that you're trying to use?
So I guess if you have a deployment, then it's just you set up your deployment, and then you don't have to worry about the pods as much. That they'll just keep regenerating as they die and change.
Yeah, so that's actually one of the biggest idea of deployments. That if something dies, something happens. Of course, you want to know why it happened, so you have logging and monitoring to check that. But you also have deployment just restarting it. So some of the 3 o'clock calls that used to happen before doesn't have to happen anymore. 3 a.m. calls, doesn't need to happen anymore.
So the container, there's deployments, and deployments have pods, and then pods have containers. Are all the pods in a deployment essentially the same thing, or
yes.
Do you have pods in one deployment that do different things, or do you keep them separate, 2 different deployments?
Yes, let's just quickly look over that, right? So you have I'm gonna just draw it a little bit lower. How do I erase stuff? Okay, here you go. So let's say you have your container right here, and that container is inside a pod, and that pod is then put in a replica set, and that replica set is then put in a deployment, right? So let's say I do a different color. So this was the pod. So this whole thing is the pod, and that has a container in it. The container is the image that you created for your application. This right here is, as we said, was the replica set.
Okay, so could there be multiple replica sets in a deployment?
No.
No. Okay.
Each deployment just takes one replica set.
Okay.
Right? But a deployment is, so replica set is also something you can directly use, but deployment makes it easier to connect to a service later. We're going to talk about service in a second.
Okay.
So you have a replica set, and replica set says how many copies, how many replicas. And I can say replica equals 4. That means this deployment is going to always keep 4 copies of this deployment, this pod. And this pod has one application, and that application is going to be the exactly same in each of the copies.
Okay.
Right? When a request comes, we're going to talk about Ingress in a second, but when a request comes to talk to one of the pods, the service is going to just pass that request to deployment, and deployment is going to round robin to any of the pods to serve the request. Right? So let's talk a little bit more about Ingress, right? So again, Ingress, Kubernetes has a primitive called Ingress in Kubernetes. So this Ingress I'm talking about just like data coming in from outside. As far as like let's say you have a web app and that's running our local host right now, and I'm sitting somewhere else, not in the same local network, I can't access anymore. So that web app is no longer, it's not a real thing to me, right? Because I can't access it. So if you have like application running on the network or somewhere in the web, people need some way to get into it. So that's basically what Ingress does. If it's in the same local network, there are cluster IP that's in the same cluster. So let's say you have a couple of applications running on the same app cluster that doesn't need people to be able to access it from outside, but your one application need to talk to some other application in the same cluster. So you can use cluster IP for that, right?
Gotcha.
Then you have node port. So node port is, the cluster you have has, each of the nodes you have has a physical actual IP address on the web that you can access. Node port just basically opens up a port on that particular node to be accessed the application. It's kind of, if you ever done some port forwarding on your router, it's kind of similar to that. The next one is load balancing. So load balancer is basically if you have a Kubernetes provider, load balancer will be something they provide, and you'll be able to then access your application using that load balancer. And the last one, I think, and the most important one to be able to use your application more effectively is to use Ingress controller. Again, I said the naming is a bit off. So Ingress basically defines all the routes from your cluster to every other application you have. So Ingress actually allows you to do a bunch of cool things. You can actually have set up a domain name if you need to. You can set up different subdomain paths, different path to send to different application. So Ingress kind of sit on top with a load balancer on top of your application cluster and controls every traffic going into your cluster. So that what Ingress does, but then you have the idea of a service. Service is, a service is what your application, like how your application becomes available to other application, be it within your cluster or outside your cluster. So service is, your service will say, I have this application that we draw before, and I have, let's say, the service that any request that comes to this service will then redirect them to that application, right? That's how a service will kind of do traffic management. And You will then connect the service up to one of the Ingress controllers, and the Ingress will know if a request comes to this particular route, send it to this service sends it to this deployment knows which part to send it to. Sounds complicated, but it actually happens all the time, regardless we notice it or not. Anything we're doing, something has to discover the service and serve the request for us. So that's what service does. So this would be kind of like a super high level overview of what Kubernetes has. What you need to know in Kubernetes just to even get started. But Kubernetes actually has a lot more things in Kubernetes. So right now what I'm going to do, I'm going to kind of show a few of the APIs in Kubernetes that we have. And to do that, I'll have to actually access my Kubernetes cluster. My cluster is running right now on IBM Cloud. You can run that on Minikube or Docker. Docker has Kubernetes. If you have Docker desktop, you can also have access to Docker Kubernetes in your desktop. So you can use that as well. So I'm just going to quickly take a look at what clusters I have. Okay.
Clusters.
So not all of them are mine. There are some so this is a shared account we use for all the developer advocates at IBM. So we have, everybody has their own cluster. I'm just looking for my cluster's name. Should start with Murphy. Oh, okay, I know. It's not there. IBM Cloud, CS, region, set, US, East. Okay. I think this should be where my cluster is. There you go. Okay.
Was it the Mofi workshop?
Yes. Okay. So it's basically just going out and downloading the cluster config so that I can access my cluster. So once I do that, I can say kubectl get nodes to just see that my nodes are working. So kubectl, that was when you said you run a bunch of commands, I'm guessing that's what you use to run a bunch of commands. Kuba. Again, the naming of it, I don't know what the right way to say it. I actually interchange between kubectl, kubectl, kubectl. At this point, I don't even know which one the right one, and I'm pretty sure whichever I'm saying is wrong. Probably. So yeah. So kubectl, kubectl, whatever you say, you're probably right. So kubectl API resources. So these are all the things that are actually in my cluster right now.
Wow.
How many of you, by looking at the list, how many of you actually used or seen before? I'm guessing you have seen namespaces before?
Yeah, namespaces,
nodes,
pods,
okay.
secrets, services,
okay.
Deployments, replica sets.
Okay, yeah.
Okay.
So again, Kubernetes is constantly growing and it has a lot of different things that Kubernetes already has. Some of those things, as you can see just by looking at it, actually comes from Istio. So not everything is default to Kubernetes. Actually, many of these things come from Istio. So these are all things that come from Istio. We're going to talk about Istio even more in this channel. But the things that are already in Kubernetes, even then there are a lot of different things that are already in Kubernetes. Things like namespaces. So namespace is the idea of, so I can just show you what namespaces I have now. First, I'll get namespaces. So namespaces is just another level of isolation on Kubernetes. You can use namespaces in many different ways. You can give namespace per application that's running on your cluster. If you have a lot of different developers working on the same cluster, you can actually give namespace for each of the developers so that they can do their testing and other things in their own namespace. You can actually have different level of resource code on namespaces. You can have different levels of permissions for individual users on different namespaces. So it's useful because then you can give a permission to a developer to a particular namespace, but they won't have permission to, let's say, override the production namespace. With that, you can also have production namespace, dev namespace, testing namespace. But many people, I think, as of now, just like use different cluster. I think, which is a good idea. You don't want to like test, even though it's a different namespace, still on the same cluster. So probably don't want to try that. So this is basically like the CLI tool of kubectl, kubectl. If you want to see like all the different things you could do with kubectl, what are the things you have seen so far? Like you have used probably. Get, I believe you use create.
Yeah, that looks familiar.
Yeah, expose probably because you had a service in your application.
Maybe. I don't remember. That was probably whenever I was just running lots of commands.
Yeah, scale, probably we use scale to scale it up. So also there are many different, than other API on the CLI tool, right? Other APIs on the CLI tool. So what would make your Kubernetes like experience a little bit better, right? Like if you were to say like, oh, I want to do like a lot of these different things. I don't want to type all these commands manually by myself. What do you think like would make that experience a little bit better for you?
An explanation of everything.
Yes, but I think as of now, I think the best way to do things we have is creating YAML files. Everybody loves YAML files.
Okay.
Yeah, so we're gonna look at a couple of those YAML files. Documents, Kubernetes, dev, app2ks. Okay.
Okay, so it's like the YAML file lets us not have to like keep running the same commands over and over again.
Right. Also, it makes you can then check in your YAML files, and this actually opens up the possibility to have some sort of CI/CD pipeline. So you can actually have the YAML files defining all your applications, and the pipeline can then take the YAML files. Because no one is touching the YAML file, you can guarantee that your application is going to be exactly the same on different versions.
Gotcha.
Because if you're manually running it, just one key here and there, you just change the application by something, right?
Yeah, I think right now I have like a conglomerate of running commands and having YAML files.
Right.
And I just don't know why.
I think, yeah, ideally you want to get to the point where you have just YAML files.
Okay.
And you just run one command to run that YAML file.
Right.
It's not the best way to do things, in my opinion, but it's the best we have as of now.
Okay.
Yeah. There are other tools being built on like to help with that a little bit. Have you heard something called the Helm?
Yes.
Yes. So Helm, for those of us who haven't dealt too much with Helm, Helm is basically supposed to be a kind of a package manager for Kubernetes. The known packages that everybody kind of needs to run over and over. You can just then say, Helm, just give me this particular thing. Give me MongoDB. Give me Postgres. Give me this one application that I know I need. So Helm can kind of like make that happen. Again, whole separate video. You can dive very deep on Helm. So we're not gonna try to do that today. So this is an application I kind of I don't know if it's still running here. Kubectl get. It's a different application that's running. Okay. So this is an application I kind of created as like the part of the workshop, and this application is basically, I called it Fox from Beta. It's basically a very dumb clone of Wolf from Alpha, which is an amazing math-based website. You can get a lot of different answers if you're looking for series and other things. So what it does basically, it computes the Fibonacci sequence up to a certain number. It computes the prime numbers are up to some certain numbers, and the factorial. So you can cd all services. And now you can see I have in total 8 total YAML files. So one YAML file for each deployment for my application and one YAML file for the service. So let's take a look at one of the deployment files. Which one do you want to look at? Your choice.
This V1 deployment.
Okay, so factorial V1, okay?
Yeah.
All right, cat factorial V1.
Oh yeah, I guess they're all V1. Okay.
They're all V1, yes. So very first thing you're going to notice if you look at a YAML file, so each YAML files of any Kubernetes primitive, you need to have few things that are mandatory, some of the things that are optional. Number 1 and 2 things that are mandatory, you have to have it, is API version. It lets the API server know where to look for the binary to run your application. So you're using apps v1. and that is the latest. The kind is deployment. We have to have that. Metadata, you have to have it. You have to say what is the name of this thing is. So we give it some name. Namespace is optional. If you don't give it a namespace, by default, it's going to choose your current default namespace. For most people, if you don't change anything, the default namespace is default. Super creative, I know. Labels is Kubernetes' way to be able to find things faster. Labels are not mandatory, but it helps you find things. It's like a key value map, right?
Okay.
Let's say this deployment from my, you're gonna see it in a second, but let's say from my service, I want to find this deployment. Then I can say, find me the deployment that has an app called this and version called this.
Okay.
So you can actually then do something where you have same application with different versions running at the same time with different labels. So you can have different deployments, but on the service level, you can just connect to the app. Then the service will then send the traffic to any deployment that are under the service.
Gotcha.
So you can do traffic routing. You can do things like canary deployment. So I'm going to say this over and over today, that many of these topics we're talking about, each of them deserve their own discussion and like really diving deep into each of them, how to do that like more better, but just to like go through each of the lines. The spec is where you define what application this deployment is taking in. Very first thing is that you're going to see a replica. Again, you and I both get replica is basically how many copies of the application I want to run.
Have 3 pods.
I'm going to have 3 pods. Exactly. Great. Awesome. You got it. So 3 pods. And this replica, if I just like change it to like 20, Kubernetes then will know I need to make 20 copies.
Okay.
So which is a very like easy way to then scale up. Not the easiest, but easy way to do it. Selector is basically saying what label should I match. It's kind of like a way for, again, Kubernetes doesn't hard connect anything. So it's kind of like this, things are in places, but you connect them using labels, if that makes sense.
Okay, so how does, like, this is a factorial and it's connecting it to a factorial?
So this part is basically what your container is going to be. So, in the picture, I drew a pod inside a deployment. So that's where you were actually saying. The pod lives by itself. Although in the picture, it looked like it was inside the deployment. In the YAML file, it looks inside the deployment. But when Kubernetes starts it up, it starts the deployment and starts the pod. It's 2 separate things. But using the matching the label, you're just then connecting that particular pod with my deployment.
Okay, so this spec right here, that's dealing with the labels of like what your containers label would be?
No, the labels of the deployment. And we're then connecting my pod to my deployment, if that makes sense. So
right, okay, yeah.
So like just to like.
That's what I meant.
Right.
Yeah.
So if you have, let's say like a pod that's running, and you have a deployment that's running. So this is deploy, and that's a pod. To Kubernetes, they're mostly running independently. And using labels, then you connect these two together. Yeah, that's basically all we're doing there. You basically say, oh, this pod, it belongs to the app, and this is name is app.
Okay, so I guess, would you have, like I don't see any like pod YAMLs.
Right. So you don't want, again, you don't want to create pods separately yourself. So we are basically saying this spec
is creating pods with, is it creating it with a label factorial, or is it telling it to link that pod to the factorial deployment?
So it's basically, we're matching the label of app factorial. That's all we're doing. So that we have a deployment that's factorial, and we are saying any pod that matches the label factorial, put it inside my client.
But if this is handling the pods, and you're like, how do you give the pods labels? How do you
so we're gonna see the pod label in a second.
Okay.
Yeah. So this is basically just like I'm saying any pod that has the label factorial that should belong. So I kind of like I kind of like make the mistake of naming my deployment and my pods the same label.
Okay.
But this label is basically I'm saying telling my deployment to look for any pod with the label factorial.
Okay.
Okay. Okay. So next time I'll probably like name them a little bit differently. But so this particular label is for my pod. That one was for my deployment.
Okay.
Okay. So next up, I'm saying strategy. So rolling update and rolling. So what does rolling update kind of sound like to you?
Whenever you push, or I guess whenever you reapply this deployment, it will like go through and only like change out a few of the pods.
Yeah. So rolling update is exactly what you just said. But there are some added benefits to using rolling updates. These are these two things: max surge and max unavailable. Let's say right now in our application we have 3 copies, and so we have 3 copies of our application. I'm just gonna draw the pods, not gonna draw the containers, but let's say 3 copies of our application. And then time comes where we want to say we want to deploy the green version of our application.
Okay.
But the black version is already running, and I want to replace them. I'm not gonna kill all of them. What I'm gonna say is first create a new copy of it. So that's where the max surge comes in. Right now, if you look at it, I have 4 copies of my application.
Okay.
Right? Then I'll probably kill one of them. Or I can then kill another one. Now I have one, like only 2 copies of my application where I should have 3. That's where the max unavailable comes in. So you can have at any given time, you can have up to 4, but no less than 2 if I wanted to have 3. Okay. Right? That's what this basically does. So basically, if you have an application that is super crucial to your operation and you don't want it to like have like no less than 3, you can just say max unavailable 0. Okay. Or if you're kind of like crunched on space, you don't have enough resource to do it, you can then say max surge to 0 and max unavailable to whatever number, and you kill that many and recreate. Gotcha. But there are times that when you don't want rolling update. Can you think of any time where you wouldn't want rolling update?
If it's like a big change that you want everybody to have immediately.
Yeah. So like rolling update, again, the part of the application, it takes some time, it slowly changes over. But let's say you had like a huge bug on your banking application and people are getting free money for no reason. You probably don't like, even if the application is down, people don't access it, it's better.
Just kill everything.
Just kill it and like do the right one right after. So there are different one other than rolling update as well. I think it's called in place. So in place basically just kills it, it starts a new one. That's where the thing you said, the pod didn't have a different like a YAML file. So this, the template, is going to define what your pod is going to be.
And then if we go back to the rolling update, I don't think my deployment specified that. So what's happening? Is it just...
So I think rolling update is what's by default.
By default? Okay.
But your application, I think you have like a big bash script to like do individual steps. Not good. But since you have a big bash script, you basically start a deployment, then scale a deployment up. So you're kind of missing a few of the other things that you can fine tune a little bit more. Okay. So next up is the template. Template, as I said, was basically from here on pretty much till the end is going to be, we're going to define what our pod is going to be like.
Okay.
And in a second, you're going to see how can pod take more than one container, but let's just go through real quick. So first thing first, you need a label. And since it's inside a deployment, it doesn't have to have a specific name by itself. But it's not bad to like, you can put a name, but metadata you need, but you don't need a name. You just need a label so that the deployment can find this pod, if that makes sense.
Okay, so you still need a label.
It needs some sort of label to be able to find. Okay. Like deployment to be find it.
And so say we change this label name to factorial pod. What would these stay as?
We would then change this one.
Okay, so change that one to factorial
Yeah. So the deployment is trying to match this label.
Okay.
To find the pod.
These two would be factorial pod.
Yeah.
Okay.
Exactly. Okay. And we're giving it a version. Again, if you want to do like some fine-tuned deployment, we're not doing it yet. In a container, this is basically just one container definition, right?
Okay.
So you're gonna see it's a containers array. That means you can have more than one container, but we're just talking about one container right here. So this container, first thing you're gonna see, always need that, is a image. So that image is the Docker image. We're going to take a look at the code that it had.
My thing doesn't have this either. So
no, because you have to have that, because when you run the deployment, directly using kubectl run, that actually sets the image.
Gotcha. But like, yeah, my YAML doesn't have this.
Right.
So you don't something I could add to my YAML.
Exactly.
Okay.
So you have that. Then you gave it a name. So that basically just helps with running the particular pod inside the pod. So if I look at this application right now, I have this particular pod. Inside that pod, I have one container that's called factorial. Again, I probably went overboard with naming everything like their exact names. So like the same name showed up a few times. But I think clearing that confusion now is much better. Yeah. This particular name has nothing to do with any of the other factorial app labels that I had. Okay. This is basically the name of the container within my pod.
Okay.
That makes sense?
Yeah.
Okay. So for example, if you wanted to look at the logs of your different containers that are running, let's say I had a factorial container, I had database container in there, then you would access that by pod name using the container name.
Okay.
If you didn't have multiple containers, you'll just do the pod name.
Gotcha.
Okay. So you have that. You have image pull policy that basically says every time you start a new pod, if you already just pull the image again. This is not super important for my one because I have like a semantic versioning on here. But some people would use a Docker image called latest. You shouldn't. But if you use a latest and you don't have image pull policy always, you might be running a like older version of your application. And debugging that is very difficult, right? So you want to have that always. This part is optional, but I think this is one of the most important part in a container resource definition. First things first, your resource. Basically, although we like to think our resources are infinite, it's not. No matter how big of a cluster we have some upper limit of how much we can get. That means also we should also know how much resource my application needs to run proper. Let's say on my particular application, I'm giving it 1/4 of a CPU, 128 megabytes of RAM, right? If I see that my application can't cope with the amount of information like data, like a resource I'm giving it, I'll probably increase it or change my application in some way. But I want to have this because otherwise, if you have like this one application that just keeps storing data in the RAM and keeps hogging all the RAM, other applications are going to starve and die, right? Also, so Kubernetes, that's one thing I think Kubernetes does really well. It actually like gives you benefit if you use like the proper way to request and limit. Because Kubernetes, each pod that you're running on your Kubernetes cluster has some sort of like value of if Kubernetes is out of resource, which one it should kill first, right? Because you can't just, Kubernetes will intentionally kill different pods to make space for something more important. It's basically just like a priority queue system. So if you have a request and limit both set and both are equal to the same thing, that means Kubernetes knows exactly how much to give you the moment you say run. So your pod is going to get the highest priority. If you have a request set and a limit also set, but each request are smaller than the total limit, you have priority but lower than the first group, right? So basically, and if you have nothing set, you get like your pod gets killed first. So if you didn't set anything, you have other application running on the cluster, you just put your application like up, it will get killed eventually. So where am I? So let's say, so three kind of pods, right? So you have request and limit, set, and equal. This is the highest priority. Request smaller than limit. This is like kind of medium priority, and nothing is basically just like kill it. Kubernetes will try to see that this particular one is running, it's taking whatever resources it needs, but it's not as priority because it doesn't have the things set proper. The next one is something you actually have to do at the application level first, or something you have to do. In your application, what tells you the application is no longer healthy?
say nothing if I go and it doesn't load?
Right. So that's not the best way to handle this, right?
No.
Right. So in cloud native, or like even before that, people were actually building some sort of like status status API or some sort of health check. Kubernetes actually helps you in like a very easy way to handle this. If you just have some sort of like HTTP route on your application that returns the health as like a HTTP 200 or like a 500 if something is wrong, you can actually then deal with that. You can also do things like, let's say you want to have some sort of file in your node that you're trying to run the pod in. You can actually check for that file as well. You can also do some sort of like TCP check. So this one we're doing HTTP GET. On my application, we're going to take a look in a second. I have a path called /health, and I actually set it up to randomly return 500, each one in every 10 time on average. So why don't we do it? Why don't we just run kubectl apply -f dot. Basically, I'm saying every single YAML file you can find in this folder, just apply that. You're going to see I just ran and got 8 different YAML files that ran. And kubectl get, okay. All right. So you just saw right now what I got was an error image pool. The reason we got that was that I'm using this particular image, which actually lives in a private registry. And this particular cluster that I'm using actually doesn't have access to access that particular registry. So I'm going to actually switch my cluster. And run that. Oh yeah, great. So in this cluster, my application was already running. And you see how many restarts I have there? So the reason I have that many restarts is because in the application I have there already has the health check set up, and it's randomly returning fail one in every 10 times. And the application has been running for 15 days. And on my UI, I don't have no fail set up. So you can see my UI just kept running, never failed, but my API other services just failed like many times. kubectl get service. So this is the application that's running right now. UI service, find the load balancer. Let's just quickly take a look. Again, it has a Fibonacci sequence, a prime sequence, and the factorial. And Nick helped me greatly with making this UI because I'm absolutely garbage at making any UI stuff. So let's just do up to 100. And it just prints out this number. I have up to 100 primes. Then I have this factorial, which looks like a Christmas tree, which is great. And each of them are running at a separate service, and I'm just accessing them manually, right? Behind this load balancer. So let's kubectl delete -f dot. Oh, thank you. I spelled it wrong again. So I'm going to just quickly delete everything and show you that there's nothing there. And you're going to see they're basically just deleting, terminating everything. So it's going to go slowly delete everything, get rid of everything, and I think eventually it's done. It's done, okay. So I'm going to kubectl apply -f, okay. All right, so I'm going to just recreate this. And you're going to see, whoa, I got image pool here as well. Great.
Got the secrets.
That's true. I do actually have the secrets. I know what happened. I have the secrets, but I think I deleted the cluster. The images are, yep, got it. Yeah, so this is interesting. So what is happening right now, I can actually, this is explainable. These images are not even stored under the same user right now that I'm using right now. So we can deal with this later. You can dive much deeper into how do you handle your own custom images. But if you have a private image registry, you need to have the secret setup. And the image registry I'm using actually is under a different account. So, you know. So when we looked at all the different API resources Kubernetes had, we saw that there's a bunch of other names we probably didn't know what it was. Let's talk a little bit more of what they are. But do you think, like when you looked at all the Kubernetes stuff that we talked about, did you think like your application, the way you built the application had to be changed in any way?
The one that I built?
Yeah.
Completely redone from the bottom.
So what's different from like building an application, like the way you built it versus the way like you see Kubernetes is doing things?
So I think I kind of, I'm not using Kubernetes appropriately. It seems like I have like just a giant monolith on a Kubernetes cluster, which kind of defeats the purpose of.
A little bit, yes. But again, the point of Kubernetes is not to like force people to use microservices. So you can use your giant monoliths, put it on Kubernetes, but you're probably not going to get a lot of benefits that you would have gotten from Kubernetes if you were to use microservices, right? Things like scaling in different levels, deploying it individually, and then like connecting them together. So this is, I think, an interesting part where people have to a little bit rethink how they build application. And that was the kind of my goal to like let people think about from your app idea, how do you get to Kubernetes? It's not different, but it's not also exactly the same. So you can do the same thing you've been doing and just get your application from here to there by just like pushing the application up. But you should probably start thinking about how do you do different things. So these are a few of the points I think like people should start thinking about when they are building their application properly. So first things first, you need to have some way for logging, right? So in a VM world, if application dies, you can then go log into that particular VM. You can see like, oh, it died. You can look at the error stacks and logs in the VM itself. In a Kubernetes, that gets a little bit tricky because every time your application dies, Kubernetes will automatically then just restart it. So that makes it a bit difficult because your application no longer exists. So you don't have that application anymore to be able to see what the logs that it created. So how do you do that? One way you could do that is have like a third-party logging service, and on your application, change the entire application code into sending log to different things. That might work, but again, you're changing application code. Even if you change the log level, then you're basically changing, you have to do a new deployment. And each time you do a new deployment, you increase the chance of that deployment failing. So that's logging. Number two is monitoring. Again, Kubernetes doesn't really take any specific stance on how do you do monitoring on your application. And monitoring also makes it like, it's different for each application, like how much monitoring you need. So if you have a CI/CD pipeline now on Jenkins or Travis, you can actually still use those. They have ways to use in Kubernetes, but what works best for you, you have to probably change up some of the things in your application. You have to have good practice on creating the YAML files. And finally, the health checks, right? Health checks, most people probably are already doing it. You should probably add one health check to your application at some point. But you have to have like good health checks, and what makes sense for your application kind of depends on your application. So let's talk a little bit about like best practices when doing Kubernetes, right? And I think I'm gonna actually start a little bit behind. I'm gonna not start at Kubernetes. I'm gonna start at the application level. What is the best practices for building the application? Number one, if you're using Kubernetes, use microservices, because again, Kubernetes does best when you're building like small application that scale up independently. Kubernetes then gives you the best benefit of resource management, the benefit of service discovery. If you have only one application, service discovery is not a big deal for you. But if you have many copies of the application, right? Also, microservice, again, I'm not saying just like whatever application you have, it has to be microservices. because not all application needs to be microservices. But if your application, if you can think of anything that microservice brings to the table as far as benefits concerned, do really think about taking it to Kubernetes as a microservice. Number 2 is try to use like a better container image. What I mean by better container image is a container image, you could basically just put a whole VM in a container image, but you probably shouldn't do that, right? There are many ways to make really good container images, and I actually talk about a few here, I think. Yeah, here you go. So, so in Docker images, if you're using Docker build, there's this thing called like multi-layer builds. I could use that to decrease your container image size immensely. You can actually take it down all the way to like few megabytes instead of like few hundred megabytes. So in that way, let me just quickly show you what I mean by multi-level builds. Many of your viewers might already know what multiple Docker builds are. If you don't know, this is, you know, we're gonna see it today. Okay, CD. Let's look at the, I don't know, the prime. So I have this Docker file, and so have you written a Docker file from scratch before?
From scratch, kind of.
Okay. So Docker file is basically just a blueprint of what a Docker image should be. So what I'm doing is I'm starting from this like Golang image as the builder, and as builder is important because I'm trying to build a multi-layered, multi-level image building. So I'm having this particular layer, giving it a name so that I can reference it later.
Okay, so could this builder be any name you want?
Yeah. It doesn't have to be called builder, but you know, most people probably call it what they use it for. I can name it Bob, but I don't think that's going to be the best idea. Okay, so then I'm doing a bunch of like Docker things. I'm creating some. This is actually super important in Docker or like in containers. If your user that are using inside the Docker image, if that user is, if you don't specify anything, by default that user is root, and if the user is root, if they somehow get out of the Docker image while running on the host image, they are then root in the host, which you don't want. You don't want, yeah. So like you want to basically.
I definitely don't have this. Is this something I can just copy and paste
Yes.
into my thing?
Yeah.
I don't have to change anything.
Not now. So basically, we're saying just create a user called nobody,
Okay.
and give them like a basically just a no permission for the most part. And even if they sleep out into the host, they'll still have this user permission, which is basically nothing. To just probably read and write like normal files, not to the sudo folders.
Okay.
Then I'm doing a bunch of other things to install my application, right? So I'm using Go to write my application. I'm just copying the right files and the right thing. So this is where my application basically is built under the /app. It's just built. But that's where I think the most important part begins. So we're just saying from scratch as final, I'm then copying my user and my application into this new image, and then building that image and exposing the port and setting the entry point, saying Kubernetes to run from this particular space.
So is Scratch, is that like a Scratch, or is that something that you named?
So Scratch is a type of an image. It's a super light Linux distribution. It has it basically has nothing. It has no SSH. It doesn't have any files. So basically, even if someone accesses this Docker container, there is barely anything to do in there, right? To be able to it doesn't have anything to access it from outside. Basically, you're just shrinking your attack vector. So if you use like Ubuntu 18.4, you're basically all the vulnerability that Ubuntu has, your Docker container has that,
Gotcha.
right? So attack vector is much bigger. So yeah, you should basically build an app this way, and I want to see if I have these images built here. Actually, don't have this image. I'm gonna just build it. Docker build -t codes prime v1.0.0. Again, this is not a proper way to version things because I didn't reach version 1.0.0 yet. but that's fine. So what is this gonna go ahead and just like build this application? But once it's built, I'll just show you this one thing that happens. As you can see, it's downloading things that are like over 100 megabytes in size, right? So you may think like this application this image is gonna be very big, but you can actually see when the image is built, it's gonna be quite small. So it's gonna go through all the steps. While that happens, I'm gonna just quickly run through other things that has to do. So as I said, small images means number one, smaller attack vector. Number two is you can run multiple copies of that image. It doesn't take up the resource.
So for the multi-stage build, so you're building it in the Docker container and then like taking just like the build and
right,
in like
exactly,
fresh.
Exactly.
Because I think I do something similar to that, except it's not on Docker. I just build it locally and then I put just the build.
Yeah, this is a similar idea, right?
Is there a benefit or a reason why I should just put it on Docker versus?
I mean, if you're trying to run it on Kubernetes, having it all built on Docker, unless you have a very specific reason not to do that, makes sense. Because if you have it in Docker, you can't accidentally change the file. If you have it in local file system, you can accidentally add different things that you didn't want to add. Yeah. So that finished happening. Okay. So if I do Docker images, as you can see, this particular image is 8 megabytes in size. It's like tiny compared to like many of the other images that I have. So as you can see, this actually downloaded two different images. Downloaded one image and built two images. One of the images that doesn't have any tag or name because that is the builder image, but that is not the image I'm using. So initially the image was 399 megabytes with all the stuff that it had from that Golang 112 image. Then I just took the binary and built the other image. That image is only 3.7.89 megabytes. So if you didn't do the multi-stage build, your image size would be actually this size. So huge size difference. Okay. Number two, so this is basically on the container size, right? You are using microservices. So you want to use build containerize. You have to build smaller images, right? So build smaller images and build more concise exactly what you need. Don't just put random things. Other best practices, and many of the best practices I said, you're going to see that actually doesn't have to do anything with Kubernetes. It has to do with other things because you're building on top of other things, right? If you're building bad application, no amount of Docker Kubernetes can save your application then. So if you build a bad Docker image, yeah, you can put it on Kubernetes as all you want, but it's not going to actually basically make your application any better. So yeah, so build smaller images, build better images, be absolutely sure the Docker image you're building is exactly what you want. Don't just randomly go to GitHub and find someone else's Docker image, because again, with like 400 lines of different things that's happening in the image, anyone can literally put any Linux command in there. So you want to be exactly sure what you're putting into your, so you have to be very vigilant in doing that, okay? Now let's just move on to like Kubernetes. What are the best practices of Kubernetes? Role-based authentication control, RBAC, is a way to, like, as I said, like differentiate between which user has what permission. You can actually set this permission to each namespace, even at each deployment and service. Like this user has write permission but not read, or vice versa. You can do that and absolutely should do that. Not everybody does have to be root or admin on your cluster. And most people that start using Kubernetes actually does that. Like, for example, in your cluster, you're by default root, and admin, you're always admin, you never change it. So basically, any command you run just goes through. And that is, again, not a safe or good way to do this.
Okay.
Again, I'm guilty of that myself, because when I'm testing things out, I probably don't have, oh man, I'm going to not create a user like that. But we should, if you're at least using it in production.
Okay.
Passwords. We should never have passwords and API token in plain text in environment variables. We can use secrets, but secrets are only encrypted, not hashed. So whatever best practices you have for handling secrets on your application level, you should probably keep that. But don't just say, oh, Kubernetes has secrets, I'm done, I'm going to put all my passwords in secrets. Because it can be, it's only encrypted, it's base64 encoded. You can just like get rid of that. So if you have some hashing mechanism involved in this, you should absolutely use that in your application level. Readiness and liveness probes. If you're not doing that now, absolutely should. We use the liveness probe on our application that was telling Kubernetes to see that, oh, if my application is ready in each interval, every 10 seconds. You also have something called a readiness probe. That one is more used if you have some need where your application needs to have something else set up before the application can perform properly. For example, you want to see if a database started. You want to see some other service got started before. So you can use a readiness probe to delay the start of your application.
Gotcha.
This one we didn't really talk at all about. Kubernetes has a really good way to roll out things. We know that already. But it also has a really good way to roll back things. Let's say you deployed something and just like failed, and you want the previous version back. You can actually go back up to like certain times. By default, I think it's 10. You can go back up to 10 previous steps. But when you deploy something, you can actually use a -- record command that records what is the current state in like a more fine-grained control, so that we know exactly what you're going back to. If you don't do that, it's still going to go back, but you're going to just not know what version you're going back to, or like what was in the version.
Gotcha. So yeah, that's what I was going to ask is, because like whenever you're deploying, you're just applying all of those YAML files. Mm-hmm. What is considered like a rollback? Does it roll back all of those, or just like each one as they come?
So hold on. So many. API resources. Just wanted to see what was the name of these things. That one is called. Time for some debugging. We're gonna just like, so what I'm trying to do basically, because my image failed, as I have a different image, Kubernetes still should keep track of what was the previous version of my application, and I'm just trying to go back to that version. So I'm gonna just quickly see how do I go back to, how do I do a rollback in Kubernetes, right? So again, that's another thing when you're trying to learn Kubernetes. The Kubernetes.io docs are one of the better docs in the tech community we have. As like we probably all know that how bad API docs can be, but this is one of like the better ones. So okay, so deployment, I want to do a rollback, rolling back a deployment, it's right there. And so rollout status, right? Okay. So I'm gonna just like do a rollout status. kubectl rollout status deployment, and let's do a prime deploy. And okay. They're all failed. I think what happened is ctl since I didn't, so basically this tried to run that thing and it kept failing, and I've probably got image pull back off, so that's just like made it happen. So I can actually hold on, rollout history. Okay, I want to do a rollout history, kubectl rollout history deployment prime. So this one, that was like, the mistake I made here was I deleted everything. I started from the scratch. So this one doesn't have any history.
Okay.
So this is the first version of this application, so it doesn't have a rollout yet because it couldn't roll out, it just failed, right? So lesson to be learned here, and my mistake, I just wanted to show it real quick. But if you're changing your application, if you delete your deployment keeps track of all the history it had.
So is the history just like on a deployment basis?
Level, yeah.
Okay.
So since
if you have like 3 deployments, you have 3 different sets of history.
Yeah, exactly.
Okay.
Exactly, and which is great because then your application can have version 1, version 2, version 3,
right,
each of them running at the same time. You probably don't want that for all the application, but there are some applications where you do want different version of this running at the same time. If you want to do those fancy deployment strategies, like Canary or like blue green, or you can do the dark launches and every other things. Those are not the most easiest thing to do in Kubernetes term, but you can definitely make it happen. So this is the one. Actually, I held it up for so long, but I wanted to talk about now. We initially talked about you can do multiple containers on the same pod, and I didn't have a good example then, but I do have a good example now. Many people, what they do is, let's say you are building your application locally. What you can do then, your database connection is like localhost, I don't know. Some Postgres is what, 3032 or something like that. So you're connecting to your localhost something, to connect to your database. You're connecting to some other things in localhost something. It works great for development, but then you go to production. In production, you have this long URL because you're using Postgres with some service. Then how people do it, basically, they have environment variables. One says local Postgres, external Postgres, and you have another production or development environment variable. You set it up, and you check what variable you have set, and using that you look it up. That's a lot of clunky code, right? That's just yeah.
I think I'm doing that.
Yeah, I mean, that's again, for most people, you're kind of forced to do it because you're developing locally. You just want to use the local version of the database, but at some point you have to say no. My production needs something else. I can't use localhost anymore. But it'd be nice to do it though, right? If you just had one code that could connect to anything you need. That's where the sidecar comes in. Sidecar can help with that. It's not always recommended, but it can make use of that. So what sidecar does, you can actually abstract away all the connection requirements to a sidecar container. Now, let's say now we're gonna zoom into our pod itself. Inside the pod, all the okay. I don't know what's happening with the shape. Okay, inside the pod, all the containers share the same local host. So let's say this is your application, and this is a sidecar. And from your application, you say, I want to access localhost 3032 for Postgres. And the sidecar actually has a list, a path that actually serves on 3032, but that just proxies into the real Postgres you have, right? That means when you build your application in your source code, you could just keep writing your local host, but handle the real connection at the sidecar proxy level.
Gotcha.
So this makes your code super straightforward. You never change your code. If you want to change your production version, just use that particular proxy. Development version, that proxy. Test version, that proxy. But your source code never changes. So if your source code never changes, that basically means you don't have to do any deployment, which is always great. Number one way to get not get failed deployments is not to do one. Like the one I tried and failed to do a real new deployment. So that's one way to use sidecar proxy. There are other applications, other softwares that use a sidecar proxy a lot actually. One of them would be Istio. Istio has a sidecar proxy that listens to all incoming and outgoing traffic, and it can do really cool things like it can do retries, it can do timeouts without you having to add anything in your code. You don't have to have any retry code, timeout code. You don't have to add, it can also do, take out information from your heading to collect metrics and logging information without having to do anything at the code level. So, if you're thinking about how in this crazy world, how do you get your data, config data and application logging and monitoring, Istio do kind of help with that. So again, Istio is a project that runs on top of Kubernetes. So for the last time today, this is something we have to dive really deep into in some other session. But today it exists. So if that's something you're really struggling with, look into Istio, and we're going to dive deep in a later session. So
you say don't use it, sidecar.
So for bootstrapping, don't use sidecar. So some people would we're using sidecar for doing things let's say I have I have to start a database somewhere. I have to like create some file somewhere. They're using a sidecar to do it before the application started. That is not a good use case for sidecar because the problem with sidecar is sidecar keeps on running for the lifespan of the pod. So the issue with that is, even though it's like just runs for the, let's say, first 10 seconds, it will keep using the same amount of resources it was using when it started, and it's just gonna hog those resources as long as the pod is living. If you make multiple copies of that pod, that's gonna multiply. So instead, you should use something called init containers. So init containers are something where it will pause the start of any other pod, container inside the pod until the init container completes. Completion is defined by you. Whatever you say it's like the init container job is. When it's done, it sends some sort of signal. It could be HTTP, TCP, or like some sort of file signal. When it's done, Kubernetes API server will know that this init container is done. I can start other containers. So once the init container is done, you're gonna see something like completed, and when it's completed, it's not gonna take any more resources. It's gonna just release all the resources.
Okay.
So if you're doing some sort of bootstrapping, definitely look into init containers. So there are some other patterns that are slowly building onto Kubernetes, like sidecar pattern is one of them. Init container pattern is something else. But again, as I said, many of these things are super new, and we're seeing more and more people use it. As they use it, we're learning what their best practices are, and as we learn their best practices, Amara, cool, yeah. So as we learn their best practices, we can then like as industry can come together and build more things. But so few of the final pointers before we finish today's talk, and thank you everybody for joining. Few of the final pointers are: if you already have an application, there's not too many things you need to change to get it to Kubernetes. The bar to entry is very low, and it's on purpose. We want people to actually be able to use it rather than having to change their entire application code. If you're writing a new application code, be mindful about the microservice architecture so that you can take the best advantage of Kubernetes if you can. When you're building container images, try to build try to take your time to build the best container image you can, rather than just getting it over with, because that's the copy of the blueprint of your applications, right? So you want to really put a lot of emphasis on that. Build smaller container images and build exactly what you need. Don't just put random things just because you might need it at some point. I've lost track of what number I'm in, but now on the Kubernetes side, you want to have all the best practices in terms of security. You want to have the RBAC controllers. You don't want your users, everybody to use just admin. If you have multiple users, even if you're using by yourself, you don't want to give yourself the chance to make that mistake, right? Use record when you're deploying things. If you're doing it from a custom image registry, set up the permissions, unlike me, which just we didn't do it and it's just failing left and right. Set up readiness and liveness probes. That definitely helps you do the right, get the application running properly without, if anything breaks, you want to know it before your customers do. And if you do need more from Kubernetes, like logging, monitoring, and other things, definitely look into additions of Kubernetes. Istio is a great addition to Kubernetes that works very natively to Kubernetes, but also gives you these added benefits. So I think with that,
before we finish,
okay, questions.
So the app that you showed with the different Fibonacci and all those things, can you just sketch out real quick what the deployment and services and pods, how that application, how that all kind of
yeah. I think I have a picture of that.
Oh, nice.
I don't have a picture of that.
You don't have a picture.
Great. I thought I had a picture of that. That is fine.
Draw us a nice picture.
Yeah. So I do have a nice little tablet next to me so that I can draw things to it. So let's just say, first things first, here's our user.
Okay.
Amazing user.
Yeah.
User kind of comes through and talks to our UI.
Okay.
But the UI itself is a service they access. So let's say this is our load balancer first, actually.
And is a load balancer, is that the service, or is that?
No. So load balancer is something that the provider you have has to give you.
Okay.
If you don't have a load balancer, you can use a node port or some sort of ingress controller. You can also create yours using Nginx or something like that. So you have a load balancer. That's like a public IP that people can access from anywhere in the world.
Okay.
Load balancer then just kind of leads to, that's our service. That's the front-end service. That is our UI. And the UI service has access to 3 of my deployments. So I'm going to just draw them overlapping each other. 3 of the deployments. So this together becomes my UI. And now you're at the UI level, and the UI you can access one of 3 microservices. I have the prime, I have the factorial, or I have the Fibonacci. And in each of individual of them are exactly the similar structure as this. So how do I copy this? Easy. I don't know how to paste. I'll just draw them again. Yeah. Oh, there we go. So, so I have another copy of Fib and 3 copies of the app. Okay, and I have as a request comes, and whichever microservice you want to access, so the load balancer randomly selects any of the 3 copies of my pod to send my request to, and each of them actually randomly selects each of them has 3 copies, so one of 3 copies to send the request to. Basically, kind of looks like, and like it just, yeah. So each of the service that sits in front decides which particular pod should serve this request.
Okay.
Yeah.
And then so these 3 blocks, those are the 3 pods in a deployment?
Yeah. So this is the service, and this is the pods that we have. Basically, I should probably draw another box as the deployment outside as well, but I was being lazy. So yeah, so you have your service. Service basically just talks the deployment.
Does the deployment choose which pod, or does the service like point to the pod? So
a service actually can have multiple deployments under it.
Okay.
On our case, we only have 1 deployment. The service chooses the deployment chooses the particular pod.
Okay.
Yeah, it's a bit like a long-winded, but I think this abstraction is necessary to be able to scale properly.
Right. Okay.
Yeah. So I think this is the any more questions?
No, I think that makes a lot of sense.
Oh, so we have a question. What app we're using? Actually, I'm using OneNote. That just yeah. JG Perrin. Thank you for the question. So we're using OneNote, and this video, if you didn't get to catch the whole thing, is going to be uploaded at some point eventually on our YouTube channel. It's also called Muffy Codes. And next week, I think you're on vacation.
Yes.
Yeah, so he's visiting beautiful Greece next week. So we're gonna be back in a couple of weeks, and we're gonna talk more about AI and Kubernetes stuff. So thank you for joining, and I've been Mofi, and this has been
Nick.
Yeah, thank you so much.